Hi guys, welcome to the Unit 2 test review video. Just as a reminder, as long as you have a completed review turned in by the beginning of the test, you will receive 5 extra credit points on your exam. So doing this will only help you. Alright, let's get started. So number 1 here, it says graph the set of inequalities. When we graph any linear lines, we need everything to be in slope-intercept form, which is y equals mx plus b. I know, yes, this is an equal sign, and we're using inequalities, but everything else needs to be the same. So what we should notice about this first inequality here is that it is not in slope-intercept form. So we need to rearrange it to be in slope-intercept form. And what we need to do here is subtract the 1. So now we have y equals 2x minus 1. And this is a line that we can graph. Let's go ahead and graph that line. Starting with the y-intercept of -1, our slope is positive 2 over 1, so we're going to go up 2, right 1. And that's going to be all of our points. Okay. Now, this inequality for this line is less than. And when we have less than and no equal to, that is going to be a dashed line. So as you may recall, or you should, when we have less than or greater than, this is a dashed line. When we have less than or equal to or greater than or equal to, it is a solid line. As for the shading, if we have less than or equal to, we shade below. And if we have greater than or equal to or greater than, we shade above. So this line, we have a less than, so we're going to shade below the line. All right, now we can go ahead and plot our other line. Our other line has a y-intercept of -2 and a slope of positive 1 over 3. So we're going to go up 1 and to the right 3. And this line, the inequality is greater than or equal to. When we have the or equal to, that is a completely solid line. Now, for the shading, it is greater than. So we're going to shade everything greater than the line here. So our shared region is right in this area. So at the bottom, it asks us to name a solution in the shared, or I guess in the solution region. I call it the shared region. We can name a lot of points in that area. I could say, let's try green. I could say like negative or 1, -1. That would be a good point. I could use any points along this portion of the line right here. So I could say 3, -1. I could say 10, 10. That's a good point. I could also say 4, 3. Anything within that highlighted region that is not along the dashed portion of the line is included as a solution. All right, moving on to number 2, write the equation given the graph. So here we have 2 lines. Looking at the blue one, this guy is shaded above, so I know he's going to be greater than. This line is dashed, so I know there is no equal to. Let's look at the intercept right here at positive 1. And our slope, we need to find another pretty point here. Looks like we go up 2 and to the right 3. There we go. Now looking at the other line, we have a solid line, so I know there's going to be an equal to, and it is shaded below, so it's going to be less than. Now for our y-intercept, it's -2, and our slope up 2 over 1. So our slope is 2. Number 3. Again, in order to graph, we need these in y-intercept form, and this line is not in y-intercept form. So we're going to rewrite it and solve for y. We need to divide by 3, or negative 3. And when we divide by a negative number, which is very important to remember as well, when you divide by a negative number, flip the sign. When you divide by a negative number, you need to flip the sign. Really, that happens when you divide or multiply by a negative number, but for what we're doing here, we're not multiplying by any negative numbers, so it's all right. So we divide by negative 3, and we are left with y, flip the sign, greater than or equal to, negative divided by negative is a positive, and 6 divided by negative 3 is negative 2. So this is the line I can graph. So we'll say negative 2, our y-intercept. Our slope is positive 2, so up 2 and to the right 3. Awesome. Now this is a solid line because the inequality is greater than or equal to. And we said when there's a line underneath the inequality, it is a solid line. As for the shading, it is greater than. So we're going to shade everything greater than. Let's plot that other line. Here we have a negative 3, y-intercept of negative 3, and a slope of negative 1 over 2. So we're going to go down 1 and to the right 2. All right, this inequality is greater than, no equal to, so we have a dashed line. And it is less than, so we are shading below. So the shared solution region is right in here, and anything along this portion of the solid line. So we could say a solution point would be negative 6, negative 2. We could say negative 3, negative 2. We could say negative 10, 0. We could say negative 10, negative 8. We could say negative 9, negative 8, right along that solid line, or even negative 6, negative 6. So any of those points would be fine to use as a solution. All right, moving down here, the directions are a little confusing because we don't have that many problems for this section, but just go ahead and use 4, 5, and 6 as substitution, and then 7, 8, and 9 as elimination. So number 4, substitution. It says y equals x plus 5. So we're going to take that x plus 5, which equals y, and we're going to put it in place of y. We're literally substituting one equation into the other. Okay, so I took that y equals, and I put it right in there. Now we can solve by distributing that negative sign. Now we can combine these like terms on the right. And combining the x's on the left. Divide by negative 2. And x equals positive 2. All right, well, we are not done here. We need to solve for y and x. So let's take the x and plug it into one of the original equations. Now we have y equals 2 plus 5. y equals 7. So our solution, the point of intersection between these two lines, is at 2, 7. Please write your answer like as a coordinate point on the test. All right, for the second one, substitution again. Here, the equation says y equals negative 5x plus 7. And so since that is equal to y, we're going to plug it in for y in the other equation. So here we'll have 8x minus 2 times our y equals 14. Let's start solving by distributing that negative 2. So negative 2 times negative 5 is positive 10. And negative 2 times 7 is negative 14. We can add that 14 to the other side and combine these two here. 8 and 10 is 18. We would divide by 18 to get x equals 14 over 9. I know that's a fraction, not my favorite, but it's all right. We'll survive just fine. Okay, now we're going to take x and plug it back into the y equation to get y. So y equals negative, y equals negative 5 times x plus 7. And when we multiply a whole number by a fraction, we'll do the whole number times the numerator and then divide it by the denominator. So 5 times 14, let's see, negative 5 times 14 is negative 70. Divided by 9 is negative 7 over 9. Y equals negative 7 over 9. So our coordinate point here, our solution point, or our point of intersection between these two lines, is 14 over 9, negative 7 over 9. All right, moving on to the next page. One more substitution, and then we'll move on to elimination. So with the substitution here, neither of these are in y or x equals, so we need to make it be that way. We can rearrange this first one to say, that's a little star, x minus y equals negative 2. We can solve for x by moving y to the other side. So now that we know x equals y minus 2, we can take that y minus 2 and plug it in for x in the other equation. So now we have negative 2 times y minus 2 plus 2y equals 2. And now we can solve for y. So we distribute that negative 2 to have negative 2y and positive 4. Negative 2y plus 2y, that gets us 0. And we can subtract the 4 from the other side, and we should get x equals negative, or sorry, 0 equals negative 2. This is not a true statement. 0 is not equal to negative 2. So do these two lines have a solution? No, there is no solution. Had this statement said something like negative 2 equals negative 2, that would have been a true statement. And so if this were the case, we would have infinite solution. But that's not the case here, so never mind on that. All right, let's check out number 7, using elimination. All right, so when we use elimination, we need to look at our x's and see if they'd eliminate each other. Here we have a negative 1x and a negative 3x. Those will not eliminate each other. Okay, let's check out the y's. We have 1y and 3y. Those will also not eliminate each other. How can we get either x or y to eliminate with the negative 3x and positive 3y? Well, if this y had a negative 3, then those would cancel out. Or if this x had a positive 3, then those could cancel out. So it looks like we need to multiply this first equation by a negative 3 to get those y's to cancel out. So let's do that. So I just distributed the 3. And now we can combine that new equation with our bottom equation. I'm just going to rearrange this to be 3y minus 3x equals 15. That way my same variables are on top of each other, and I can easily combine them. So negative 3 plus 3, those cancel out. 3 minus 3, those cancel out. And negative 15 plus 15, those cancel out. So we're left with 0 on both sides. Does 0 equal 0? Yeah, that's a true statement. Because it is a true statement, in this case we have infinite solutions. All right, number 8. We're using elimination, so we need to find how we can make either these x's cancel out or these 2's cancel out. Looks like we need to change the sign here. If this 2 were positive, then those y's would cancel out nicely. Let's go ahead and multiply this first row by negative 1. Distributing that negative 1, we get negative x plus 2y equals negative 6. Now we can combine that with our second row. X minus x, those cancel out. Negative 2 and plus 2, those cancel out, so we get 0. And now we have negative 6 plus 2, negative 4. Does 0 equal negative 4? No, that is a false statement. So again, we have no solution. All right, for number 9. Here we have elimination again. So we need to eliminate either the x's or the y's. Here our y's are 1 and 1, and our x's are negative 2 and 4. So let's just make this easy by changing one of the y's to be negative by multiplying by negative 1. Distributing that negative 1, we end up with 2x minus y equals 6. And I want my x and y to line up, so I'm going to rewrite this with 4x in front and y second. I can do that because the x and y are already on the same side. If they were on different sides, then yes, I would have to subtract or add them to the other side. But the y and x are already on the same side, so flipping their order doesn't change anything. All right, so bringing that other equation down, 4x plus y equals 12. So just as I wanted to, those y's are going to cancel out. 4 and 2 is 6, and 6 and 12 is 18. Divided by 6, we get x equals 3. Now to find y, we're going to plug this 3 into one of our equations. We can say y plus 4 times 3 equals 12. 4 times 3 is 12. We would subtract the 12 over to solve for y, and y equals 0. So our coordinate point, our intersection point between these two lines, also our solution is negative 3, 0. All right, moving on to number 10. Here it says rewrite in a matrix and solve. So when we rewrite these in a matrix, oh, I didn't solve for these yet. Great. Okay. So when these need to be rewritten in the matrix, we need to make sure that they are in standard form first. And standard form is x first, then y, then z, equals to a constant r, where r is the constant, which I also call our plane numbers. This is a number without a variable. So let's check. This in standard form. We have x, y, z, constant. X, y, z, constant. x, y, z constant. Yep, those are perfectly in standard form. So I can go ahead and start fixing up our matrix. So our first matrix always starts with the coefficients. And our second matrix is always the constants. So starting with the coefficients, our first coefficient here is 1. Our next is 2 and -3. Next column we have -2, -1, and +2. Our final column we have 3, 1, and -2. Now for our constants, 7, 4, -10. And put this into the calculator. Give me a second to get this calculator going. I guess I could pause the video. Let's do that. Okay, so as a reminder, when you put the matrix in the calculator, the directions, the calculator instructions are menu 7, 1, 1. And you can just hit the numbers. Hit 7, hit 1, hit 1. And that'll give you the option. You need to know how many rows. This is 3 rows by 3 columns. Sorry, that is so messy. But so this matrix is a 3 by 3. This matrix, the second one here is 1, row 2, row 3. This is 3 rows and 1 column. So make sure you type that in the calculator correctly. Okay. Once we get all that going, our answer here is -2, -15, and -7. So when our answers come out, that's always going to be in the correct order that we put in our coefficients. So this is x, this is y, and this is z. So we can say our coordinate point is -2, -15, -7. Or you could also say x equals -2, y equals -15, and z equals -7. Either one of those is okay. All right, moving to number 11. These equations are not in standard form. How do I know that? Well, the first one has x, y, z constant. This one's good. The next one, we have a constant, x, z, and then y on the other side. So that needs to be fixed. And this one too, we have x, y constant, but this z is on the wrong side. So let's get to moving these around. So here, with the second one, we need to rearrange that. So right now we have -17 plus 3x plus 4z equals 2y. And what is wrong here is that we have x and z. Those are good, but this needs to be moved over here, and this needs to be moved over here. So how do we move a 17 to the other side? It's negative, so we add it. Now we have 3x plus 4z equals 2y plus 17. Okay, now again, we still need to move this 2y to the other side. How do we move it? Well, it's positive, so we will subtract it. And we do want the letters in order, so we're going to say 3x minus 2y plus 4z equals 17. If your letters are not in the right order of x, y, z for every single equation that you put into the matrix, your matrix is going to give you completely wrong answers. So don't rely on the calculator to give you the right answers when you're not telling it the problem correctly. So here's our corrected equation 2. Let's do the third one. Here we have -6x plus y. Well, these are both on the left side, and that's good, but this is good too, but the 7 needs to go to the other side. So we're going to subtract 7z. And now we have -6x plus y minus 7z equals -12. And now that is a good equation to put into the matrix. So now, thinking about all three of our equations, our matrix will be 2, 3, -6. 5, -2, 1. And then we have 2, 4, negative 7, negative 1, 9, another 1, so negative 38, 17, negative 12. And sorry, I probably should have written all the equations together. I know that's kind of confusing, so let's do that. So we'll have 2x plus 5y plus 2z equals negative 38, negative 17. Oh, sorry, I'm starting with the wrong one. That's this one here. So 3x minus 2y plus 4z 17. And then the last one was the new one we wrote over here. Negative 6x plus y minus 7z equals negative 12. So this is what's being put into the matrix. All right. Yeah, and as long as you set this up right, you'll get the correct answer. I didn't solve for it. You can do it yourself. Okay, here, find the equation given the matrix. So here we are writing the equation. We are not solving. We are just writing the equation. So this is going to be our first equation. And then our second equation will be the second line, and the third equation will be our third line will be the third equation. So what's happening here is we have R, S, and T in that order. So this is going to be R, S, T, R, S, T, R, S, T. So our equations will be negative 6R plus 5S plus 2T, negative 11, negative 2R plus S plus 4T, negative 9, 4R minus 5S plus 5t equals negative 4. It's that easy. All right, let's do the next one. Our letters here are x, y, and z. X, y, z. X, y, z. X, y, z. All right, writing our equation. 2x plus 3y minus 2z equals 8. X plus 0y minus 4z equals 1. 2x minus 1y minus 6z equals 4. All right, this is important too. Right here, I wrote in a 0y. If this is one of your multiple choice answers on your test, this second equation might be written as x minus 4z equals 1. 0 times y means there's no y. So either writing that in or not writing it in, you still have the same, like mathematically the value is the same. So whether it says 0y or no y at all, it's the exact same. So make sure you recognize that if there is a question like this on the test. Hint, hint, hint. All right, last two. Is that the last two? Oh, thank goodness. Okay. Last two. Bill went to the store 3 different times. The first time he bought 2 apples, 1 pear, and 1 pound of strawberries for $11. The second trip he bought 3 apples, 4 pears, and 1 pound of strawberries for $19. The third trip he bought 3 apples, 6 pears, and 5 pounds of strawberries for $43. How much did he spend per item? Well, first we need to write some equations, starting with the first one. Let's say 2 apples, so that's going to be 2a, 1 pear, p, 1 pound of strawberries, s, equals $11. Next equation, 3 apples, 4 pears, 1 pound of strawberries for $19. And the last one, he bought 3 apples, 6 pears, and 5 pounds of strawberries for $43. How much did he spend per item? Well, we're going to fill out the matrix and find out. So if we write in the matrix, ooh, that's way too small. We put all our coefficients. The negative 1 times the answers, the constants, and we will get our answer. As long as you type this in correctly, you'll get the correct answer. Again, I'll let you do that on your own. And for the last one, Miss Kennel, she bought 6 pairs of Yeezys, 1 pair of Jordans, and 4 pairs of Adidas for $40. She also bought 6 pairs of Yeezys, 5 pairs of Jordans, and 6 pairs of Adidas for $56. And then she went back and bought 5 pairs, 2 pairs, 4 pairs for $35. All right, starting with the first one, let's write equations. 6 Yeezys, 6y. 1 Jordan, let's say J is Jordan, and 6 Adidas, so 6A, and she spent $40. Next equation, 6 Yeezys, 5 Jordans, 6 Adidas, $56. And the last one, 5 Yeezys, 2 Jordans, 4 Adidas, $35. Put that right into your matrix. 6, 6, 5, 1, 5, 2, 6, 6, 4, 40, 56, 35. There you go. All right. If you have any questions, please try to come see me before class tomorrow. Again, your review needs to be completed and turned in by the beginning of class. And for my classes, all of your missing work needs to be turned in at the time of your class tomorrow for the test. After the test, I will not accept missing work. Okay? All right. Good luck. Have a great evening. Bye.